Okay. So again, we are in 7-4 today. We are going to do a problem with area of a triangle. That's something I'm going to expect you to know for your upcoming tests. We are going to do a partial fraction decomposition. That did not make it onto the test, but I do believe it's a good skill to practice. And sometimes I enjoy doing something a little bit harder in class and then make it a little bit easier as we get into the test. So we're going to kind of challenge ourselves on something here. We're just going to do one of these, and then we are not going to do any of the number 3. We have spent time graphing rational functions. We did it in Algebra 2. We did it in first semester pre-cal. I just, it's not relevant to matrices, so I'm just not going to worry about it. So you're welcome to just cross that off. And then on your homework, the third problem is one of these. Since we didn't do it in class, you don't have to do it for homework. And since we're not doing it in class, it's not on the final, it's not on anything. We've already tested that. To me, I already know whether you know how to do it or not. We're not going to do it again. Okay. So we're going to start 7-4, and I'm going to get rid of my calculator for now. I'm going to come back to it later, but I'm going to get rid of it for now. The first thing it says is find the area of a triangle with vertices A, B, and C. Let's pause and let's draw this triangle really quick. So we're going to draw this triangle. We're just going to sketch a little graph here. Sure, I haven't taken attendance on this reason. Okay, continue graphing your graph. I'll join in 1 second. Once I see who's here. All right, so now I'm going to graph my picture. Now, no, it's not going to be perfect because my like dashes are not exactly the same distances apart. It's just a little imperfect, but that's okay. Now, we have done area of a triangle a couple different ways. When you were like in the, I don't know, 3rd, 4th, 5th, 6th, 7th grade, do you remember what they told you area of a triangle was? 1/2 base times height. Very good. 1/2 base times height. We're not going to use that one, but that's one that you know. Do you remember the one I taught you last unit with sine? Yeah, you remember doing it? We had a formula sheet, so I'm okay if you didn't remember it. It's going to be 1/2 AB sine C. Okay. We are also not going to do that one. We are going to do one that comes from a matrix. We are going to do one that's area equals 1/2, and it's going to be the determinant of a matrix that we're going to make. So this is the one that we are going to use. And we're doing the determinant of something called a directional matrix. Over the years, I've cut a few things out of like our academic pre-cal curriculum just based on time and just also based on kind of importance of what we're getting you ready for and what have you done before. And one thing that we used to do that we no longer do is a unit on vectors and polar coordinates. So we're basically looking at a vector right now to make these directional matrices, okay? We're looking at what we call the vector AB. And it's got this little, here, I'll even draw it a little bit lower. It's got this like half arrow on top. And I'm also looking at the vector AC. Now, we could do it from any point on here. I often like to pick the lowest point, but we could do it from B or from C. It doesn't matter. So you just have to always start from one matrix. And we're like, okay, how do we get from that one point to the other point? And then how do we get from that first starting point to the third point? So we're doing two kind of directions off. Vectors happen or are kind of informed to us about their horizontal distance and their vertical distance. So we care about how far left and right you moved to get there and how far up and down you moved. So we're going to start, if I go from A to B, let's think about how far left or right did I move here? And you can even just count. We went 1, 2. I think I just went 2 spaces. And that also makes sense because I was at 1 and then I went to 3. So I just went 2 spaces. And then I want to think about how much up and down I wanted to get up there. I went 1, 2, 3. And again, my graph isn't perfect. So you have to either count or you have to think we were at -1 and now we're going to +2. So I had to go to 0, I had to go to 1, and then I had to go to 2. So that's 3 spaces. And we write vectors in what you guys are used to as like a coordinate point form with like the parentheses around it. That's how you would notate a vector. Okay. We're gonna do the same thing with AC, okay? Now this time we're going to the left, how many units? We were at 1 and we're going to -1, 2. But since we went to the left, we're gonna call it -2. And then we're gonna go up to C. And we were at -1 and now we're going to go up to 7. Good, 8. So the horizontal distance and the vertical distance now give us this vector, and we're going to relate this into what we know. We're just going to make that a matrix. So I'm going to put the horizontal distances are my first column, the vertical distance are my second column. Or you can think of the first row is my vector for AB and my second row is my vector for AC. The hardest part is finding this matrix, and then the rest of this is easy because now all we have to do is 1/2 times the determinant of this matrix. Do you remember how we find the determinant of this matrix? We're going to do 2 times 8 minus 3 times -2. So 16 plus 6 is 22, right? No, we don't come up with this in this problem. I do wonder if on our homework or in the future, always just take the absolute value of that. I didn't think about it yesterday, but the more I've been thinking about it, that might be a problem that you might have. You might be like, why did I get a negative number? It's an area. True. So if you get a negative number, just do the absolute value of that. I think that that should work out the same. And so now when I do the area, I'm just going to do 1/2 of 22. And what is 1/2 of 22? 11. So the area of that triangle is 11 units squared. And you don't necessarily need the units with it, but I think that that helps kind of humanize it and make it make sense. Right. All right, so there's a problem like this on our notes. There's a problem like this on your homework. There's a problem like this on your next test. Go ahead and flip it over. Let's do partial fraction decomposition. We could go way more in depth with this than I'm going to. So we are just going to kind of lightly skim the surface. And again, this next part is not on your test, but I do think it's important to talk about. And we're just going to do letter A for just kind of ease sake. If I think about it, I might do B on my own, or you could probably go look at my old videos and find B. I've done it. It's just I don't necessarily want to do it today. Okay, so we got to do a few steps when we do this partial fraction decomposition. The first thing I want to do is factor the denominator because that's going to help us understand what we're even doing with this problem. So we want to factor the denominator. So when I factor x squared minus 2x minus 15, what do we get? Are you guys all quiet because you know it already? If not, I'm really stressed out. Everyone's okay with that factoring? Okay. I just factored it out. I just factored the denominator. Okay. When it says we're decomposing it, it means we're breaking it down, we're breaking it apart. So I'm arguing that this fraction that was given to us, 5x minus 1 over x minus 5 times x plus 3, can be split into 2 fractions. And each one has a denominator that is one of those factors. And that's something over x minus 5 plus something over x plus 3. And that's going to get me to that 5x minus 1 over x minus 5, x plus 3. Okay. The confusing part here is what I'm going to use as your variable. I can't use x because we already have x in this problem. I don't want to use y or z because that's something a little bit different. I use, in kind of the notation that we use in matrix algebra, is a sub 1 and a sub 2. We use those because those are different enough, and we're going to solve for those later. So we won't deal with them for a very long time, but that is my variable. I know that doesn't look like a variable that we're used to, but that counts as a variable. Okay. So we factored the denominator. The second step that we just did right now is to separate the fraction. Okay. Separate the fraction. We need to solve for our a sub 1 or a sub 2. So we're going to solve by clearing the denominator. So we're going to start our solving journey. And we're going to do that by clearing the denominator. And we did that back in, I don't know, chapter 1, 2, 3. I don't really quite remember the chapters anymore. But we did this in one of our chapters where we got rid of the denominator. And what do I do to get rid of the denominator in all of these? What do I multiply by? Good, x plus 3 and x minus 5. And if it's being multiplied and it's in the denominator, then it completely cancels away. And if it doesn't cancel away, I've got to multiply it by that numerator. So in that first fraction, both my x plus 3 and my x minus 5 cancel. So I'm just left with 5x minus 1. Okay, cool. In my second fraction, my x minus 5 cancels, but my x plus 3 does not cancel. So that means I don't just have a sub 1, I've got a sub 1 times x plus 3, because that did not cancel, only that x minus 5 canceled. And then very similarly in the last fraction, the x plus 3 is going to cancel, but the x minus 5 isn't. So I have to do a sub 2 times that x minus 5. All right, this is messy. However, notice that I have an x term on the left and I have a constant term on the left. What we're going to do is we're going to distribute this a sub 1 and this a sub 2, and then we're going to clump my x's together and then clump my constants together so that we can solve for that a sub 1, a sub 2, okay? So let's distribute. It's going to get a little messy before we're allowed to clean it up. So distribute that out. A sub 1 times those two, a sub 2 times those two, and so I get 5x minus 1 equals, and I'll even go first, x a sub 1 plus 3 a sub 1. And then I've got x a sub 2 minus 5 a sub 2. Now we're going to group our like terms together. We can't actually combine them, but we're going to group them together. And that's actually the next step. I've used the word combine like terms. I'm going to use the word group like terms. I think that makes a little bit more sense. I want the two x's to be next to each other. I want the two constants to be next to each other so I can easily set up an equation. So I still have that 5x minus 1 by itself. I'll deal with him in a second. I'm not ready to yet. And then I'm going to put my two x's together. So I'm going to do x a sub 1 plus x a sub 2. Those two are going to go first. Then I'm going to do my two constants together at the end. Plus 3 a sub 1. And then minus 5 a sub 2. Notice that my equation now kind of nicely lines up. The first two things and the first one there both have x's in it. The last one on the left and then the last two on the right both have no x's, they're just constants. Now we're going to write two equations using that, okay? We're going to set the gray parts equal to each other, the x's equal to each other. So I've got 5x equals x a sub 1 plus x a sub 2. Now, technically, since I have X in all of those terms, I don't need to write an X. I could divide by X on from everything. I don't need that X. And so that X can go away. Since there was an X in every single term, I can just cancel it. And those, if you notice, those are all my gray terms from earlier. Now I'll do my blue ones, my constant. I've got -1, 3 a sub 1 minus 5 a sub 2. And those are all my blues. Okay, this is where this relates to what we're doing. We can now put this in matrix form, and then we can solve this any way we want to. We could do inverse form, we could do RREF, we could do Cramer's rule. Technically, we could do substitution or elimination. We could solve this any way that we solve like a systems of equations. I like RREF, and I feel like I told you that. So if given the choice, I'm always going to use that. So I'm going to write an augmented matrix, okay? The only thing that's funny is that our solutions always go on the right side. So even though my 5 and -1 are on the left, I need them to be the last two numbers. My 2 by 2 matrix that's going to go on the left here is going to be made up of these coefficients. So the coefficients in front of a sub 1 are going to go in my first column. So it's going to be 1 and 3 will be in that first column. And then my coefficients in front of my a sub 2 is going to go in the second column. So 1 and -1. Oh, I don't know why I had, that's weird. That should be 5 and -1. Sorry, my solutions were wrong. I took 5 and -1 from over here. That's why those should be there. So you need the answers to always go at the end. So we could have actually written this equation as like equals 5 instead. And equals -1 instead, if that makes everything line up a little bit nicer in your head.
So why is it doing it wrong?
And then now we're going to go put this augmented matrix in our calculator, and we're going to press RREF, and we're going to have the answer. And we're going to see what a sub 1 and a sub 2 should be. What should those numbers in the top of those fractions be? So see if you remember how to input a matrix. See if you remember where RREF was. I'll be quiet. All right, I got my answer when I did RREF. Do you guys get what I got? Now, the cool part about this is that first one is my a sub 1. And my second one is my a sub 2. So when I go back up to that original function up here, instead of writing a sub 1, I could have written 3. And instead of writing a sub 2, that answer is 2. And so this equation is now a true statement. 3 over x minus 5 plus 2 over x plus 3 would give me 5x minus 1 over x minus 5x plus 3. And we could solve that out to prove it. I don't need you to do so. I'd argue that we've already done enough. But that is what it actually evens out to. I would write my answer like maybe even a1 equals 3, a2 equals 2. And honestly, you could probably even just leave it in that matrix form. All right. That's really all I got for today.
You know, that's like this guy that you have with the.
Yes. And I guess the very last step I could say is solve with And again, we have a lot of ways that we can solve with matrix. We could have done Kramer's rule. We could have done inverse method. We could have done just REF, but I think the best, easiest way is RREF. So a little bit of player's choice there. Okay. That's all I got for today. So we just have homework for the rest of class. When I see you next class, we're gonna do 7-5, then we're gonna review, and then we're ready for a test next Friday.